Welcome back to the podcast, everyone. Once again with Henry. This is probably our last episode of the season. When you say Henry, I can't.
I think so.
So
unless we do a recap, but I think we'll do that at the beginning of next year.
We're welcoming on our show Paul Depmore, who is someone I've known for longer than I care to admit.
I've got evidence.
And someone who's been on the podcast before.
Yes, a hidden appearance on the podcast.
A hidden appearance.
Do you remember, Paul?
Nope.
We got him on when he was loaded, so he spewed all the stuff. You talked about using a micrometer as a sequence.
Oh, yeah.
And how that's good practice.
Yeah.
And how you're bringing...
Podcast at a brewery. That's a great idea.
Yeah.
Nothing bad could happen there.
That was awesome. So for those of you wondering, it was our live show for an NCSLI at the, what is that called again? Metrology on Tap.
Metrology on Tap. Yeah, it was in Texas. I don't know the year. I just remember
probably one of our most popular YouTube
Texas
videos, and everyone loves Henry on it.
I was pretty feeling it.
Yeah, you had a good buzz. Well, Paul, welcome to the show. The first thing we always do is ask people to share their story of how they got into metrology, because it's not always an easy path. Our paths collided in Miramar. So Why don't you talk about how you got into metrology?
Yeah, so I was, so that reminds me, we went to GCAMs, right? And I'm tired of you guys having these snobs on your podcast that say it's Lowry or nothing. They're not allowed.
That hasn't happened since season 1, though. The Lowry snobbery has kind of gone away.
Yeah, it's time to retire the Lowry snobbery. Yeah. Anyway, I was stationed with Ryan. I actually have a picture.
Oh, look at that! Look at those buff dudes.
This sexy devil here. And then
look at me in the back.
Look at that.
Yeah,
that's right.
So I have evidence.
I love that.
Look, he called himself sexy and then said, "Here's Ryan."
Well, you're sexy too, right?
And I mentioned the Depot Level Labs last podcast. Remember, Henry, I was talking about how we used to have those in the Marine Corps, and that's there MCC3 Mobile Calibration Complex. That was considered a Type 1 lab.
Yeah, so we serviced the MALs, right? There was all the West Coast MALs sent their standards, a good portion of them. It was interesting, Ryan. I went to a NAVAIR meeting before I left, and there was some high up staff, NCOs, and they were petitioning to bring the MCCs back.
It makes sense. I mean, it was such a good idea. You know, what's funny is on the last show, Tim Mason, I'm sure you know Tim Mason from MSC.
Yeah, he's a Lowry guy.
No, but he knows Top Cornet. Like he's like good friends
they're
with
good
him.
buds.
Yeah, which is funny.
I talk to Tim often. He's a good dude.
So you came in through the Marine Corps, boring. So you did all that stuff, right? So we did all that. So what did you do after the Marine Corps, though?
So that's the origin story. I went to a Southwest Research Institute in San Antonio, and really cool standards. But there's this old grumpy dude, and the boss hired a bunch of military, just me and a couple Air Force cats. And as soon as we came in, he came after us, and he had the pocket protector and his pants pulled up way too high, and immediately just started in on us. You guys don't know shit. You're not worth a dang. You never taken data. You don't know uncertainties. And so I didn't like the guy right out of the gate. It's like, screw this guy. And then it was a lot of, you can't do this. You don't know this. So my origin story of Star Trek got me there. So this guy had really hacked me off, and then I tried to pay him a compliment. He really put us down low. You guys don't rate. So I paid him a compliment, and I was like, hey, that's a really nice class ring you have on there. And the way he talked, I figured it was from some university. I was like, what's that ring? Where is it from? He's a Star Trek officer. So I was like, something snapped in my brain from that moment on. It's like, I'm going to learn everything, I'm going to learn. Right. And I'm going to do it better because I'm, when you get out of the Marine Corps, it takes a while for you to become normal.
I don't like the guy either. Just because you don't like them, I don't like them. But there is a small
That's
amount
how
of
it
truth.
works.
There's a small amount of truth to that, right? Like we come out of the military. Me, like I came out after retiring, so I'm like I ran labs, I
Oh,
taught
wow.
at the school, and then you go to the civilian world, and it is different. But yeah.
So that's what got started. I left there, went to a semiconductor plant, which was awesome. They have all kinds of cool tools and process that I was on the dry etch team.
Nice.
And they like the silicone. It's just science fiction, right? Like they supercharge the wafer with a high negative DC value, and then they bring it down to a low vacuum. They insert some nasty gases over the top of the wafer under a high vacuum, and then they spark those gases with an RF signal, right? And the different polarities get drawn into the wafer. I mean, it was awesome. I just was like, this is the coolest stuff I've ever seen. And that was like one of 25 processes. And they didn't calibrate anything, so I was short-lived there. My calibration brain couldn't handle it. So it makes sense. They're measuring the end product, right?
Oh yeah.
Seeing how much failure they have, and they had so much redundancies built in on those wafers since it was a RAM that they could say, hey, 76% of this wafer is good. They're fine. So they were trying to metrology was all backwards, right? We're noticing defects at this portion, so they would go back and tweak tools that way.
Oh, wow.
But all the instrumentation that was used on each of these tools, none of it was calibrated. So I that wasn't for me, right? It bugged me too much. So that I ended up at the big old Houston Transcat lab, and that was awesome. It was a whole bunch of jar heads there, really cool capabilities.
And I have some pictures of that on my LinkedIn and stuff, like because I went and taught. I taught it there. I taught a couple days there, and man, that lab is really cool.
It's got some really cool capabilities. Back when we first started off, it was the labor was cheap, was the deal, and then you had a whole bunch of hungry jar heads. And I didn't know it at the time, but the director handpicked the auditors, and then he put us in front of them. We had nav lab for a good long while. That's where I really learned stuff, right? But it was a bit of this. I do have history. This is me working at the lab. Yeah,
that's awesome.
Yeah. So I'd work 20 hours, and then I would go to the shipping and receiving, and then go sleep in the peanuts. That's how old this picture is. We had peanuts.
Do you miss sleeping in peanuts? Is that a good experience or a bad experience?
It's not. I've slept on worse. That peanuts are just fine.
We've never had someone.
I've never heard of.
No one's ever come with their own photos, Henry. We need to demand this. I love this. This is awesome.
It's freaking awesome.
So I was in Arizona, and Alex
awesome.
Bautista, my best friend, he found this, and so I was like, oh. Yeah, I got challenged at one of my labs. They were like, one of the guys asked me, and we hadn't met. We don't know each other. We're in good terms now. But I walked into the building. He stopped me, and he's like, I just need to know, have you actually ever calibrated anything in your life before? And I was like, was having a good trip. And that guy said that. So now when I travel, I'm going to bring this. I don't have any pictures of me. Yeah. I don't have any pictures of me touching buttons. So I did that for a good long.
We all believe you.
You can get one. Cal. You can get some pictures of touching buttons.
Yeah. It's cooler when you're 27 touching buttons and then you're pretending at 45.
I know. I wish I had more pictures of us inside the vans, because when I explain it to people, like they're like, you worked inside calibration vans. I'm like, they're square shipping containers that are this awful green color inside. Like, why that green? You know what I mean?
Yeah.
There's probably a reason.
Speaking of pictures, I have a picture of when I met Henry way back. He doesn't remember. He was a rock star back in the day.
Oh,
This is me at the Smashing Pumpkins concert with Henry.
Oh my!
Right there. This is before he went emo, right? This is the good time.
Yeah.
So
Yeah,
was
I
like,
have
catch
better
that
ones.
concert.
I have Henry.
bullet with butterfly wings. Yeah.
I have
You had a
videos.
good hit with that
When
one.
we started, Henry's been there since the beginning of Cyan, and his first videos, he's probably what, Henry, like 60 pounds heavier, 80 pounds heavier?
Oh, not
Nowadays.
that much.
Oh.
I was probably 30, 40, maybe.
No
I don't
way.
know.
It
I'm
was
like
a lot more.
190 now. I was 225, 230.
Okay.
So yeah, 35, 40. It all goes to my freaking face though, but we won't.
Your face, yeah.
It just goes.
I gained weight in the face too, so I understand. So
It's like Garth Brooks used to be thin. Like you'd look at him on stage, but he'd have this face as like, yeah, it's like, wow. Yeah.
So I'm glad you mentioned that though, Paul, like Transcat being a good experience, because all the time I get people transitioning, right? And they'll contact me and I'm like, just let me know the places you're applying to, like especially if they're friends of mine. Like I had a good friend of mine retiring, and I'm like, just let me know who you're thinking of and what, so
Sure.
I can make sure you're going somewhere that will take care of you. Because so many people drop out after their first one lab, maybe two. They go
Sure.
to one bad one, especially if you're coming from the military, where we're somewhat trained in that aviation mindset, that NAMP mindset, right? Of like, we're important, we can't let these things slide. And then you go to the quote unquote naughty labs, the bad labs, and they're like, oh, it's fine, it's whatever. And you're like, no, I'm not going to do this.
So we're kind of on that tightrope where I asked y'all not to get me fired. I worked at Transcat, and at the time it was good. Just I think it's fair to expect, if you're gonna go commercial, that you're gonna put some hours in.
Mm-hmm.
That's the expectation. It's been almost 10 years since I've been there. I now work at Applied Technical Services, and that's the best place in the world to work.
Which one, Paul? I mean, we were.
No, that's right.
Oh, no,
so there's different
I spelled it out.
ATSs, but
Okay, so we were talking about that. Just there's two ATSs,
At least,
and there's
yeah,
that we know of
that are
right?
large in Cal. There are at least
large in Cal. Yeah, so you said it. So
American is out here, and there's a relationship with the Navy, but their big thing now is the mock software. And I don't know if you guys know Robert West, but he's over there with them. He's also a jarhead, and they're doing really cool things.
Nice.
Well, that's cool.
So yeah.
Well, we might.
Yeah, and then
I was just about to say, I shouldn't say. Well, we might have someone from Mox on the podcast next season. So
cool.
Yeah,
maybe
if
they like Ryan by then.
They'll like
if you
Ryan.
don't ruin
They have
it.
to find him sexy. Yeah. Now they have to find him sexy. So.
But then I went to Illinois, and I met Henry, and me and Henry were friends immediately. There was no butting of heads. There was no difference of opinions. We were.
I remember the first day you called me. You gotta be shitting me this standard. What are they wanting us to do? And I'm like, oh wow. So after like at first I'm like, who is this guy? What the hell? And like after about 10 minutes where he explained himself, and I was like, oh yeah, okay, we're gonna get along great. But the first 10 minutes were like, what the hell?
Who?
Crash
Paul?
course into the ASTM world. Yeah.
Paul is always calm, cool, and collected. Never, never a rise, never alone.
It was hilarious. I still remember that. I'm sitting there. I think it was in the afternoon too. I think it was like late in my day. It was like 4:30, 4:45. Something. It was somewhere in there.
You're just trying to end the day, and
I'm like, man, he's really wrapped on this. I could take it to the committee, but they're probably not going to care.
No, they would not care. But Henry sat down, and we walked through all of this stuff, especially on the E4, E74, 75, the ISO 7500, 376 stuff. And him and his team just sat there, and we would go through cals. And that's, I think, the biggest part of my success is being able to talk to vendors and not be afraid to be wrong, right? Because if I'm wrong, that means I'm going to learn something. And Henry's a perfect example of that. I'm starting to be able to work again with Jay Clevens at Ohm Labs. That's another just fantastic resource. And I think the heart of it is got to be nice to each other. This community,
Oh, yeah.
that's I in my mind is the biggest problem is we're not getting along, and everything that we calibrate needs to be calibrated. And there's some great resources out there, and so just being decent to one another is, I think, a big takeaway. Specifically, if you're getting out of the, military, treat those guys right, the new ones, and be encouraging in every step. But yeah, so I'm over at Morehouse. We're looking to buy a calibration frame, and the RAM on there had the term effective area. And I had just come out of 4 or 5 years of deep diving into piston-gauge calibration. And then that's where Henry helped me out, and we built a force multiplication frame using Henry's force frame and a Ruska deadweight tester. And that was pretty cool. And I'm hoping that one day we can sit down and actually line that thing out, maybe do something commercial with it.
Yeah, we there's a lot. You and I have talked offline about force multiplication systems and hydraulic amplification, and hopefully we'll be working with NPL and bring you in on some of that the discussions. I've told you a little bit about it. Getting one that does like a 50-to-1 or even a 500-to-1 would be the end goal, because that would just be insanely awesome to have different ratios and stuff. But yeah, it's going to be a long process to get where we need to get to, and I can't officially say some stuff, but there's some funny stories along the way on NMIs and doing different things and the uncertainties that are claimed at certain levels, and whether they may or not, whether they self-regulate or not on some of these things.
Yeah, the piston gauge uncertainty path is like a bit of a spider web. It is a bit convoluted, but they do a lot of work to get those. I mean, I think in the force world, not you, Henry, but some other locations kind of put the pressure down here, and I don't think they realize all the effort that's being made to claim. I'm seeing 13 parts per million on some piston gauge platforms. And the higher pressures, of course, you're going to get closer to 50, 70 parts per million. But that's good enough to calibrate a load cell.
That's insanely good. Yeah, it's just getting those tenets, plumb level, square rigid, low torsion, getting those, and then driving it with the pressure. We're always looking at it. I mean, it is cool. We have some people that are really passionate about pressure, and that whole field is just expanding. I mean, we can throw names, but Adatel's doing some awesome stuff, and there's some other companies that are not. Like, there's complaints that they can't get service. We're starting to hear more and more of it, that, hey, we got to buy overseas. There's not anything in the U.S. for this. And it just depends what you're doing and what kind of gauges from what I'm hearing in the general industry sentiment about it. And Ryan's into this too. So Ryan, you probably hear some stories. Like, if your standard pressure gauges, all like calibrators, all that, Adatel's doing fantastic stuff. Fluke's has their in it, but then a lot of the stuff from overseas now that was coming over that people were relying on aren't offering service, and you're getting nailed with tariffs too. So there's just not that huge amount of players when you get into the primary pressure.
Yeah, that's the hard part, is there's no competition, right?
Yeah, you're definitely limited if you're looking at a primary level, which I don't even know if you need. For piston gauges now, we got to be careful using the term deadweight testers. You have Fluke, and you have DH overseas, or that's under the.
No, we have some students that do listen to this. You want to explain why you want to be careful calling them deadweight testers?
Yeah. If you read the NIST document, it's about this thick on deadweight for pressure, right?
Yeah.
And there's some really good information in there. And I would say this much of it is for piston gauges, right? Piston and cylinder.
About a third.
Yeah.
And it's the only major reference I can find. Like, I have books back here. We're trying to get some references for students that they can go buy and stuff. And like, that NIST document's like one of the only ones I can find for pressure.
Yeah. I'd say the last 2/3 of that document are around a floating ball gauge. ball gauge, the dead weight tester, the ball floats in a nozzle.
Let's talk about this then. Talk about this first with the students, and then we're going to talk about you know where I'm going with this. I'm going to ask the question that everybody talks about.
So
no one wants to address.
This design was way before my time, was put into place at Ruska, and Ruska was kind of like the creme de la creme back in the day. And what I was told was they sold these units, and then they came back, and all of them failed. And that's because it's not regulated. So the piston cylinder, the pressure is regulated by that very tight clearance between the piston and the cylinder.
Mm-hmm.
There's a mechanical regulator that's separate from the ball and the nozzle and the dead weight and the floating ball. Now, again, I wasn't there. I don't know if those stories were true. I can just tell you that we lost money repairing and recalibrating ball gauge testers. It's still being sold, but at a primary level, if you can live with loosening the tolerance significantly, then fine, it's good enough, right? But if you're trying to claim the uncertainties, at the time of calibration after repair, I can get it to be 0.015% or 0.025%, but not over any real length of time. So that's why I got to be careful. I've got to spell out piston-gauge dead weight testers. And then, of course, there's the Henry dead weight testers, dead weight for force.
Right.
Yeah, different. And then there's the case that we had on the huge dead weight testers.
Yeah, Case is his name. His name. He's
Case
from
V's.
Case V's. Yeah. He's from the Netherlands, and he does high pressure. Like, what was it?
High.
I know 100K. I've heard of that guy. He bought the Harwood. The Harwood system is now in Marietta, Georgia.
Yep, he bought that, and he was talking about like his life and how they launched a railroad tie, I think, in the air where they didn't see it, and then it came down.
Yeah,
it was that much pressure. So,
yikes.
A guy with a lot. Going back to what you were saying earlier, just there's so many people with all this experience that it's hard to replicate. I mean, a guy like Case comes out, he learns, he bought the Harwood stuff, went over to the Netherlands, and then he has all this experience and says, oh, it's easy. But I don't know if it's that easy as he says. And then I talked to our guys, and you guys, there's stuff there. So I wanted to get back to the one piece though, and this is that you get you in trouble, probably not, but I always ask people on the dead weight systems where you have to clean the equipment prior to calibration, and I think this is all. Everybody has their own opinion on it, but if you're a lot of the opinions that I've heard is if you don't clean these systems when they're sending to you for calibration, they're not going to calibrate. The ball's not going to float. Like typically they come in all gunked up and everything else. So I just wanted to get both of your guys. I don't need to put Paul on the spot, but both of your stances on these systems and what do you generally think?
I thought the maintenance for those was yearly too, like on their PM where you have to replace the fluid.
No, but I'm just talking about the ball. I'm talking about the floating that ball. Like I've seen it like in labs. We do not do pressure, so I may be naive on this, but I've just seen labs and they're like, what are you doing? They're like, well, we got to clean everything before we do the cal. I'm like, is that an as received? Is that not an as received?
Oh, I see what you mean.
You know what I mean? Because a lot of people that send the equipment in may or may not be doing the maintenance and cleaning it. So
there's two different pieces to this, right? You have the pressure component, which would be the piston and cylinder or the ball and nozzle. And if they're dirty or gunked up, the machine's just not going to operate properly.
Right.
Most of the time you don't have to clean it, especially if you keep it in the oil that's used, or even the 2465, which I think is like the tightest clearance on a pneumatic system. It's not gonna operate. So there is a pretty in-depth cleaning process for the piston cylinder stuff. Not not typical. Most of the time it's floating and it's operating fine. The secondary piece is all the dead weight associated with it.
Yeah.
And there's definitely two trains of thoughts there, and you see it when you go get your mass sets calibrated, where they find something out of tolerance, so they clean it and then re-report the value after they cleaned it. So, but they only do it for the out of tolerance ones. So I mean, you see where I'm going with this.
Yeah. So it's an interesting. Yeah.
Yeah. If I, money and time were no object, I would offer it to the customer. Do you want us to clean prior? Right. Because there's an argument that the artifacts got gunked up in the shipping container. Right.
Yep. Yeah. So, because you're sticking it somewhere it's gonna have contact with something.
Yeah. So what was typical for us is on the dead weight testers is we would pull out each individual piece, shoot it with alcohol, wipe it down, let it sit next to the balances and scales for comparison. So clean the first day, ready for weighing, right?
Mm-hmm. Get that soaking in.
Yeah. That's just what we did. I've seen it done differently, but I think at the end of the day, if you're doing a lot of dead weight or mass comparison or weighing, you offer it to the customer. Do you want us to clean before we measure, or do you want to measure as is? I think.
Yep.
Well, and doesn't this come in, Henry, sometimes to when we talk about process control, right? Like, and there's been times that I chat with clients and they're like, well, what would you do in this situation? And I'm like, well, is it this important? How important is this in this process? And when we're talking about cleanliness, right? Like, because most places, if it's their main standard, right, they'll keep hopefully the weights under some sort of control, to limit the dust and all that stuff, right? But I've seen places that have PM schedules for weight cleaning, right? And it's because of they need that, right? But they also have a way to measure those weights inside their own process, right. Whether it's because those weights can widely vary, right? Because you got up to aren't some of those like 5-pounders or something like that, and then all the way down to little gram weights. So you have to have quite the scale range. But places that it matters to them, it matters to them their uncertainty that they're claiming, the customers that they have, they keep track of those weights and they see the deviations. Like I'm thinking off the top of my head, this customer that they were showing me, like they check monthly or. Was it monthly or whatever?
No, that's
check
all good.
All their weights to see if they've
control charts.
Yeah.
So
because everyone always thinks of like, hey, I could do control charts on my 5560, right? I make sure to keep checking my voltage or whatever. They don't think of weights, things that people are actually touching and getting dirty and all those things. But
that's right. So in the piston-gauge stuff, if you're looking at an uncertainty budget, the first thing, the most dominant component should be the effective area of that piston. That chews up the majority. The secondary component, the second most significant component in that budget is going to be the mass. But unlike, precision comparison where I'm wearing a glove and I'm smocked up, tweezers, all that craziness, it is. You don't want to, most of the time, you don't want to be wearing gloves when you're operating the piston gauges because there is a lot of moving parts. So it is very typical that you begin the rotation by actually touching the weights. Right. You want clean hands, but it's not as pristine, let's say, as like a mass comparison.
Right. But you don't want to just have eaten chicken wings.
Don't want to do that.
Before you start.
Or be currently eating chicken wings.
Wait, what's wrong with that? The grease. I got some grease on that weight. That's
yeah. I mean, that makes sense to me. But
no, that's one of the things, though, right, Paul? The biggest disadvantage probably is the safety part of things. So you're just being careful not to drop any of the weights on yourself.
Yeah. I mean, if you don't break something, you've never calibrated anything. If you think about the higher pressure stuff, the pistons get insanely small, and then you have a whole bunch of weight on a. So yeah, that weight starts wobbling, And that's a steel weight. If it's a carbon one, it just explodes.
And correct me if I'm wrong, but isn't there some, and I'm not pointing anybody out in particular, isn't there very common services to calibrate these dead weight testers, piston gauges, where they try and they do the cross float, but they never, like, over a certain amount of time, they've never actually checked that area. Do they only check it by mathematical methods? Like, there's no intervening way of checking it, is there?
Yeah, I mean, so when you talk about effective area, it's the relationship of the piston to the cylinder, not necessarily a dimensional measurement of what the area would be. I'm saying that, so yeah, most of the time a true cross float, so a known pressure and a known mass, will give you you can solve for the area, right? Well, that pressure is, and this is where it starts weaving together. That pressure, that primary pressure that you're supplying to this secondary deadweight tester, well, there's an effective area in that as well, right?
Right.
So this is where if you look at the NIST chain, or look at Fluke's chain, it's because they're better than NIST currently, and I'd like to talk about that. It's a spider web. So I do believe at NIST level, what they will do is both. They'll do the cross float, and maybe Fluke too on their primary stuff. They'll do a cross float, but they actually do take dimensional measurements. I don't know, it's like a check possibly, or maybe they're trying to, because there's a deformation component, right? There's no pressure applied when you're taking a dimensional measurement, let's say with that smoking hot CMM they have in the basement. But at the the higher pressure you go, the cylinder starts deforming.
Sure.
The piston cylinder starts deforming. So there's some coefficient silliness that has to go in there as well.
Man, cool. You're really opening some worms.
No. I mean, this is, again, all way before my time. I just got really lucky, and there was this dude named, I'm sure a lot of the guys know it, and the best metrology mind I've ever had the pleasure of working with was Ken Kolb, and he just blew our minds. He put us through the ringer for a good number of years, but it's just the best guy, and that's where I've gotten a lot of my knowledge.
That's awesome, though. No, so a little bit on that. Though, but yeah, so you had an awesome mentor, right?
Yeah,
it was hard, made it hard, right? It didn't make it easy, but he challenged you, and now you're just spurting. You're not even doing pressure hardly anymore, and the passion is just exuding from you right now on it.
I raised 3 kids doing this, so it's got to mean something, right? That's where that component is. We bought primary pressure systems for the Navy, the NPSL lab, right? You'll get a kick out of this, Ryan.
Well, wait, hold on. You got to tell people that you went into the Navy after that, though.
Oh, yeah. Then I went to the Navy.
Then you went to go work at the Navy. That catches us up.
Oh, that's right. Yeah, that's right.
So was that after Transcat, right? Yeah. After Transcat to the Navy?
No, after Transcat, I went to an ASTM. They specialize in mechanical testing calibrations.
E4.
So this is all cool stuff. This is all Henry's family, right? Mm-hmm. So back in the day, they were putting buildings and bridges together, and they started failing, right? And we started making a lot of steel when steel was cool, right? It had to be tested very specifically, and they came up with a lot of these tests. And there's these testing frames, is what they call them, and then big, huge, hydraulically driven machines that will pull steel apart. So to be able to perform those calibrations, you have to take an elastic device, right, Henry? Am I doing all right?
Yeah, you're awesome. So
it was a very specific ASTM E4 calibration that had to be performed. And that was to calibrate the force on these tensile frames. And the elastic device of choice back in the day was the proving ring.
Yep.
And
like we're in the 30s and 40s. Yep.
So the proving ring is unwieldy, but some really smart guys over at Morehouse not only would calibrate them via dead weight, because that's required, but there was also they were addressed to temperature. So even you calibrate these things in the smoking hot lab. Well, I'm going into a steel foundry, right?
Mhm.
Yeah, in Chicago,
Regularly,
around
right?
the Chicago
Could be
area.
cold, could be hot, right? All over. So there was a temperature correction that needed to be made, and this is before calculators.
Oh,
So all this stuff was mapped out, and I've heard all kinds of crazy stories. But if you can think about
curves.
having
Yep.
Was there an
Yeah.
abacus?
No,
Sure.
I would not seen that. I've not seen an
Dang.
abacus being used in metrology. That's the picture the three of us should be using. Abacus, or your next class at Sign, abacus for metrology.
Abacus reading, yeah.
Yeah.
So that evolved to the load cells, right? Then the load cells, they benefit just the reduction in weight more than anything. But now it's got software. Now all the curves are done for you. Henry was adding cals. He'd get load cells of such high resolution that you could actually put 2 sets of calibrations on a single load cell. You reduce the amount that you have to take on site, and all this work is done on site.
Yeah, your setup times, because breaking setup, then you re-exercise and all that. So yeah, there's
Henry's they're checking the boxes for labs like CalRite. That's the lab in Illinois. But in the ASTM E4, one of the first lines in there, it says, "Thou shalt not pass go unless you use ASTM E74 calibrated device," and that's what Henry specializes in.
Yep. No, that's good. That's a great explanation. Yep. That's the American side, and then the other side, you said ISO 7500. The ISO side is that correlates to ISO 376 for some of the European standards, and some over here. If the companies, you ran into these too, Paul.
Yeah.
If the companies are, usually they have to be owned in some or under some guidelines with Europe that they request a 7500 from my understanding of it. So I know the standard very well. I just don't know why some are requesting it over here. The assumption is that they're trying to meet criteria to ship things overseas as well.
Yeah, I never asked them, but no. So like, if you're doing E4 calibrations, you need E74. If you're doing ISO 7500 calibrations, you need 376. So the E74 and 376 was requested from Henry. So the goal was, before I left, to get every last one of our, I don't know, probably close to 40 working load cells. Every load cell had the ASTM and ISO calibration on it. So we weren't having to play. It's a real logistics nightmare. These load cells go on a job. Oh crap, this one's got the ISO cal on it, right? Not only capacity. So we worked real hard to get both ISO and the ASTM calibrations on those working standards. And then I went to the Navy.
In the Navy. Then he joined the village people.
The Navy.
Into the Navy.
Civilian side, though.
Civilian side, yes. That was cool. Eye-opening. We had taken a field trip to Corona back in the day when we were at MCC. You remember that?
Yeah.
And that's kind of like the only way you could get back there is you had to have a security clearance or a reason to be back there. But that's where they write the procedures. But on the NAV-C side,
you were NAV-C, not NAV-Air, right?
That's correct.
Yeah.
You going to talk about the submarines being sexy or no?
Submarines are sexy. I don't remember.
Nothing.
Then there was that's a separate part of the Navy. You would think that submarines fall under NAV-C. They do not. So it's another one of the 15 navies that are out there.
I just remember a guy that interviewed for us one time in an engineering position, and I go, "Well, what do you do?" He's like, "Well, I design latches for submarines." And I was like, "Well, why do you want to come work with us?" And he's like, "Because I design latches for submarines, and that's all I do." And I'm like, if we hire this person, the Navy's probably, or this company, it wasn't Navy, this company's probably losing their expert on latches for submarines.
Oh, no.
They now don't have any workable latches, which in a submarine is a problem.
He's like, "It's cool, but it's all I do." And I'm like, yeah, this poor guy, like, you got to get sick of seeing latches day in, day out for, like, I could tell you that model subs latch.
That's crazy.
Yikes.
I know. Anyway, sorry, it interrupted that one, but yeah, that was funny.
Sexy latches.
Yeah. Design them with some flair.
Well, you were saying that being in the Navy or on the Corona side was eye-opening.
Yeah. And it's full circle, right? So like you got thrown into you do the military thing. You think you know calibration. You get into, I don't know, industry. It's not only commercial, right? The institute's not commercial, but it was 17025. So I'll just say the 17025 world. And right out of the gate, you're taking data. Everything's got to have an uncertainty, right? So it's like, whoa. So you come all the way back to where all the expertise, the SMEs, they're there. So there's procedure writing going on, but for me, it was we're modernizing. I kind of helped. I was the technical lead for the internal ILCP for NAVSEA. Ginger had a whole bunch of artifacts that she would send to NIST or Morehouse or some really nice stuff, right? And then we would send those artifacts to all of our labs. And that lasted for a while. I just did the technical side, right? Just the EN stuff, which was way more complicated than it should be, right? So if I have an artifact from NIST and they give me, they give me all their coefficients and they give me readings with an uncertainty per each point, slam dunk. Then what you get back from Navy labs, and it's no fault of their own, they give you readings, but what's the missing part?
Yeah,
I ain't got
no uncertainty or anything like that.
No, why would they have an uncertainty?
Right.
You back calculate and say for your EN to be 0.9, this is what your uncertainty is. What? That's too high.
So it made some good relationships with the Navy labs, because it was like, all right, I'm going to be grading you. You're going to be graded on this. You don't have an uncertainty. Let's work on an uncertainty together. Mm-hmm. So with their technical manager, there would be a bunch of back and forth with an email. I need some repeatability data, right? Kind of point me to your traceability. This is what I think your uncertainty is. Do you agree? Please know that you're going to be graded on this. It was backwards, right? Mm-hmm. For sure. But we all learned something, right? Especially the labs. I feel like they got a better grip on, okay, it's not just the accuracy of this tool that I own. There's other things.
It's not just the standard involved. Right? We were talking about this before we started. Yeah. People, when I start breaking down, we've started integrating uncertainty into our lower level stuff because people can't wait anymore to learn this stuff, right? And when I teach it in person, it's always kind of an aha moment of how big of a deal that repeatability or the procedure basically is, and how people are performing the measurements are really important, not just how accurate everything is.
Specifically on the mechanical side, right? Like the dimensional stuff.
Oh, yeah.
That stuff explodes real quick. It's all environment based.
Everything
is yellow. Military, because the environment, like those double wides, whoever thought that was really going to work? Like those double wides holding a plus or minus, 1 or 2 degree. Yeah, right.
Well, that double wide, you remember Gunny Dahl? I think he's the one that he read the letter of the law and saw that we didn't rate it, so he got that taken away from the MCC.
Well, we had a hard sight.
Yeah. Oh, I see what you're saying. The double wide van. I hear you.
Well, because I then subsequently went and worked at a MALS, which for those of you listening that aren't in the Marines, aviation logistics squadron. So these are the things that support the aviation wings that have all the aircraft. We were a part of those. And in some places, Cal Labs are attached to different components. It's a weird thing because like they don't know what to treat us as. But yeah, so when I went to further wing components, like up there at Pendleton, I was the NCOIC up there, and we had a double wide that they were trying to do,
trying to eke out the environment.
Yeah, trying to do like super mic stuff in it. And it's like, you can look at the chart here. It's been, every time the whole fan thing kicks on, it plummets down, then comes right back up,
That's crazy. Yeah. Hey,
You didn't do it quick. I got 3 minutes to take my measurement between the air cycle.
Well, there's no concept of soaking, right? Of saying, hey, like we
Right,
need
you
to have
can't.
all these
Yeah.
components in the same environment for a long period of time, and it all stays the same time. It's just it's not even possible how it's set up, and it's funny that we ever thought that it could be.
Well, that reminds me. Greg Senker tells. I think it's his story. Maybe it wasn't his, but it was so. I think he went to a lab, and he was looking at the data, and it was like every day at X around X there'd be out of tolerances, and here it correlated to the actual air conditioner was blowing like around the same time every day.
Yeah, with no diffusion or anything. Like in these vans, Henry, like these things are hard, like serious air flowing. Just
right, yeah, because it's pretty warm. You're probably in a sunny area, I imagine.
Flight line, all concrete.
Yeah. Oh yeah.
They moved. Yeah, it was the Mouse 39 van pad. They moved that to Al Asad, Iraq. And I distinctly remember the humidity being a problem. So we would walk the van pad, and just pour water. Just pour water on the ground just to get the humidity
down a bit.
No, up. You got to
up. Oh, because it was so freaking dry there.
Yeah. I don't know what they did or what they're doing.
Yeah. For whatever reason. I thought it was just, super hot and you were cooling it down.
This is funny. So I'm with the Navy now, and we would go out. There's a Guam facility, and they have 2 tenders, and they support other boats. I'm not a ship dude. Shame on me. I was there for 4 years. I still don't know what boat does what. Anyway, on these tenders, they're trying to perform calibrations, right? And in the corner, I'm looking. I'm like, holy shit! Each tender had an old Morehouse force frame. They were trying to do, and then I think Ron Kelly found this. We gave him the serial numbers, and he pulled them back from like the late 70s or something. They were trying to do force calibrations on a ship.
Oh, that makes
not
sense.
Small force stuff.
Well, all you got to do is, just wait for it to stop rocking.
Well, this is my Jack Handy quote. I think I'd be better at pinball if it was on a ship. Because...
Well, anyone that has deploy, I unfortunately had to deploy. Like you try and do pull-ups on a ship, and you'll be like doing 1 million, and then you can't do one, and then you'll do 1 million, and then you can't do one.
Oh, that's how you get your pull-up goal. That's the recommendation. Is just get a ship.
Test when it's on the other side.
That's funny. That's how we get our PT requirements for pull-ups.
So buying standards for them for the labs. We had 15, 17 labs. But this now, because I wanted to talk about the NIST component. It was time to buy the new primary pressure system, the stuff to calibrate the 3689. That's what it's for, right? So the only player in the United States is Fluke. So we bought all the new PG systems. NavAir bought the PG systems for the primary lab in North Island, right? And they're rocking and rolling. They've got automated cross float systems, state of the art. It's fantastic. First year, they're banging them out. It's good. Good group down there. James Wagner. I don't know if y'all have met him.
Fantastic. Yes. Yeah.
Guy, man.
Yep. Absolutely fantastic.
Super smart. So, no problem. Now NPSL's pistons are due for calibration. They have to use they're by the law. They're traceable to NIST. It's not. Or an NMI or the SI unit. It's you got to send these to NIST. They go to NIST and they come back, some cases 2-3 times the uncertainty that Fluke was able to provide. Why is that? That's because NIST is still using the older Ruska stuff, right? And I love the Ruska stuff. But, And really, you want to do a 1-for-1 combination. And Fluke has got this method where I forget what it's called, base ratio, and I don't know. They do if you have the same model, you swap the mass and you reduce the uncertainty from the mass by doing so. You do a cross float this way, and then you do anyway. They've got all this cool stuff they're doing. They've got their uncertainties approved. I'm sure they've got a bunch of proficiency tests. So it's not like flukes in question here. It's like, well,
right,
what's going on with NIST? And realistically, and now NPSL is kind of at a standstill, right? They're looking for authority to continue to use fluke. Well, if the letter of the law is thou shalt use NIST, this is where I think it's been really easy for me for decades now to like kind of poke and prod at NIST. It was kind of on us, the procurement arm. If the limitation is NIST can't provide what we're asking them, then we should buy NIST the correct cal standards. You know what I'm saying?
Okay.
The DOD at the time, the DOD.
Yeah,
right?
that would make sense.
Instead of complaining all the time, we should have reached out to NIST. We should have marched right over there and said, "Hey, we have this problem. We want to fix a problem. How much would it cost? Are you interested in doing it?" Now that would have solved the problem for the Navy, right? But it would also it would have made all the American calibrations better, in my mind, right?
Sure.
It would have made NIST better. So instead of complaining about it, it's kind of on the DODs. Yeah, I said it to make them whole, right?
Yeah.
Instead of complaining about their turn time and on and on and on.
Right.
What are we doing to make NIST better?
Man,
anyway,
Yeah, 'cause
that's a good way of looking at it, though. Like, I wish. See, this is the type of stuff that is severely lacking. In my opinion, this is all just my opinion based. That's lacking in our field is we're so insulated, and we've always been so insulated, and then now we're at a point where some of these things, you know, we need people like Paul out there saying, like, are we thinking about these measurement issues the right way, and are we doing the best thing for the whole industry, right? So,
yep. And knowing that it's government and funding buckets might not be there. I went to things for torque where NIST was thinking about doing torque. They do not offer torque measurement. There's other parameters that they do not offer. Typically, we are fortunate in the United States that NIST is usually the lowest uncertainty for almost any parameter. Paul is just, I tell you, torque they don't do. Paul's got one right there with the standards that they're just probably not the lowest because of what they're doing. Now, I don't.
Sure.
Well, you got to talk to NIST, yeah.
Ryan knows you see a lot of high pots in a commercial lab, right?
Yeah.
The mega stuff, right? That traceability chain does not exist. NIST does not provide high voltage calibrations.
Yeah, so that's another one. Yep.
So there's just stuff that NIST does not do. And now you don't need super accuracy for high pots, right? The megas, it's by design. The accuracies are pretty reasonable, but you do need a traceable path. So we would have to go. Jay at Ohm Labs got his uncertainties down enough, which were more than adequate. They were, I think, right in line with some of the NMIs. But we were regularly having to trace through the NRC in Canada and eventually the PTP in Germany. You have to, right?
Yep.
Which would calibrate our Vitrex or our secondary dividers, which would calibrate, the megas.
Which I'm surprised because this is normally they're looking to add a lot of that stuff. Last time I was down there, they were looking, and they probably have added it. They were working really hard on some AC voltage references.
Okay, cool.
So, and they're also working on a lot of dynamic force stuff. In fact, they got one of the world's renowned people. We've almost at that point. I don't know where we are now, but we were 10 years behind Germany, and this guy came in, and they had really closed the gap for dynamic force.
Oh wow!
So dynamic force is that vibration?
Yeah, you get a bunch of stuff. They were using 34. I'm going to get it wrong, so I'll get what I know and just know that it may be wrong. It's like you have four parameters. You have some electrical, you have a table, and then you have a mass weight. That's three of them. There's one more that's in there. They had some 3458s. They had a table, and then they had a known mass, and they'd accelerate that, and measure it. And I think they were trying to get up to one kilonewton because that
That's
was
right.
a lot of yeah.
The larger the mass, the harder it is, correct?
Oh, it gets so difficult because I remember going down there and I got to talk with them on this and started looking at all these commercial labs selling the stuff that had these ultra low uncertainties, and were completely unobtainable because we have the best people in the world working on it, and they're claiming something like 01, 02, somewhere in that neighborhood. And then you see these companies saying, hey, we're 50 parts per million, 005. Like there's no way.
No way.
This sounds like vacuum. Vacuum's like that, where you see some really wild claims, and then when you work in vacuum, like when you're going past like, it says I'm down to 0 psi. No, we're talking like you're getting into torr and millitorr type vacuum. You're like, hold on, I think some of the places out there are a little bit wrong.
Yeah, there's a lot of that are wrong.
Spider sense.
Yeah,
we see it.
Vacuum gets crazy. So it sounds like that's the same thing with what you're talking about.
100%.
Yeah, and you just don't know. Some labs just do these cals and they never get audited, or they get audited for their uncertainty and no one sees it. You're going, Paul works at how big's your scope? How many pages?
Oh gosh, I mean, our largest scope we call them the FOCs, family of companies, right?
Yeah,
our largest one is the Marietta, Georgia location. Marietta. See, this is I live in Murrieta, California, so I have to correct myself. Marietta, Georgia, and that scope is I want to say close to 50 pages. I'm guessing.
Right.
But that facility is really cool because it's 7 or 8 cal labs separated out, and then the testing's combined in there. So they do mechanical testing. I just came back from the Arizona location, and they're doing some really cool battery testing there. Like and what a cool little lab that is, because it's a cal lab right next to some really great, smart electrical engineers, right? Hey, I'm putting this 100 amp, 1000 amp current shunt calibration standard. This is literally last week. I'm standing this up. Can you please make sure I'm not going to kill myself, right? And the he's in there. He's helping us out. There's a machine shop located. So the testing and the calibration are close knit. And then in return, we're going to be able to calibrate their 1000 amp current shunts at that location, right? So instead of so
it's a win-win.
That's
right. I mean, they need that. They need someone to certify that their stuff is in cal, and it's probably for their process or whatever they're doing, and you guys are there. But yeah, I just, when you look at scopes that are 50 some pages in some of the labs, it's tough. I mean, there's a lot of parameters and stuff on there. I'm sure you see it all the time with different ones. I mean, you're not going to get everything right the first time through. It's like several years sometimes to go through. And then when you add stuff, you learn a little, like we're all learning along the way. So, I mean, I know I've had people say the Fluke 8588s, the 8508s, those uncertainty budgets, my goodness, they're like, it took me forever. And I was through so many people, and I just did not get the help. And then Fluke, if you use their, and I recommend using Fluke, they're great. But yeah, their absolute uncertainty includes the uncertainty of their reference. Like everything's included in there, and you do your own repeatability studies and everything else. But when you start using these instruments, it gets confusing if you're not into that and doing what we do is ratiometric and looking at the specs. And I had to ask so many people, even in Fluke, to get me to people that was like, okay, well, here's what it's in the man. Well, here's how you do it. I said, well, you look over the budget. Yeah, we'll look over the budget. And then we got to like, 8 parts per, I think it's 8 or 9 parts per million at full scale. But in everything that you do, the percentage of range is like a constant, and those numbers get quite large at low readings. And even NIST, the use of Joseph Junction, they don't take readings below, I want to say 0.47 millivolts per volt. They can't go lower. So, and the uncertainty starts getting larger, and they use a pooled standard deviation. So if you envision at 10 millivolts per volt, they're like super tiny, right? If we're doing this for a viewer, say we're an inch, by the time we get to the 0.47 millivolts per volt, we're at like 10 inches. It's like 10 times bigger, your error bar on this, and it's just going to keep going up down to zero. That's just the thought process of it. But yeah, people don't consider this.
Help me out here, because I'm hearing you talk about this, and I've for years now I'm hearing you geek out on the electronics, and you've made a real huge improvement on your frames, where like there's no question you can compare on your automated force frame comparison process versus your dead weight process. I'm imagining they're on top of each other. Well, if you're selling
they're
it's
close.
on top of each other.
They're close.
I'm giving you a compliment here.
Yeah, thank you. They're close.
So help me out. Why are we geeking out so much on the electronics? Because the dominating component it's a limitation of the load cell itself, right?
No,
are you in competition? What's going on?
I'm not. No, there's no competition. It's just for years I've been wrong with it. Like personally, I've been wrong with it. Is you look at something and you see somebody's scope and they say, hey, I make these measurements and it's 6 parts per million, and they're going to NIST using pooled standard deviation. And all I'm saying is they can only measure from that 0.47, which is in general only like 5 to 10% of the load cell. Well, it's not even 10. It's like only like 15% of the load cell's range, somewhere in there, from 15% to full scale capacity. So when you say these ultra low numbers, why I geek out, as we started earlier, is because the resolution of the instrument's not in there when somebody says like 6 parts per million. You take one count out of 400,000, or one count out of 1% of that load cell of 4,000, the percentage is just through the roof. But people claim like 6 parts per million. So we're changing our scopes right now to add back a constant to say it's okay. Yeah, it's 8 parts per million plus this constant that's applied throughout the range. But that's the only reason I'm really geeking out, because at low measure, really low, millivolt, microvolt, millivolt per volt, microvolt measurements, the uncertainties just blow up percentage wise. And I've yet to see people do this right. So it's one of my things. And we were doing it wrong for eons. And I went through, all I'm saying is I had to go through all these people at Fluke. I had to do this. I had like 5 auditors. I had people in the know that were doing it. It's an argument for like NCSLI, MSC, helping one another as labs, and just all sharing the information so we can get things correct. That's why I'm geeking out on it, because it's been bothering me for a while, based on just that percentage. Whatever.
You have a specialty widget too on some 3458s that NIST provided you.
Yeah, that's a voltage divider. Joseph and Bilecki did some stuff back in NIST. It's just a series of resistors that are wired together because of the way the 3458 works. It's unless you stack 2 of them and do straight voltage on one side and millivolts on the other to get the ratio is quite difficult. So they made us this box that adds some uncertainty to things, that we start the day taking these resistance measurements from this box, and then we key in those numbers, and we have years of data on it. But I can tell you, we're switching to the Fluke 8588.
I get it. You guys, I get. What I'm saying is any interest for Jay to tackle something like that? Because I could see a lab like us
on the boxes
using a 3458 with, is Jay taking a look at those? We would definitely be interested in something like that.
Your pain point is every time you start a cal, it's not just simple shift 0. It's shift 2, 4, I want to get this right. I think it's you have to set the 3458s to do special things, and then you
Right.
set it up to put in this ratio. So it's 2-4.
That's right.
You enter in this large ratio 7, and then you hit 1, and and half the time I'll tell you, Paul,
And you hope it takes it.
You hope it takes it. And as a technician, I remember I just want to calibrate this load cell, and I'm like, it didn't freaking take. I'll do it again. It didn't freaking take. And then finally it takes. And sometimes it takes and there's some offset. And I'm like, what the hell do I do with this offset? Like typically I'm getting like U, which is super small, like 1, 2 counts. Like I'll start my 0 at 1 or 2. But when you enter all this in and then you get your number switches to M and the decimal place is way over, you're like, well, that can't be right. I can't start my cal here because that can't be right. So there's a lot of doubt. I have OCD. So when I doubt something, I just re-key it in and all this. A lot of doubt, and all the testing that I did and everything else. It's the text, and then you have to monitor. You have to have a log to monitor what's going on with that resistance. You have to build a box. Jay could build one. You have to build that box. You have to build. You need to be careful that you don't have all this stuff. So it's just there's a lot of stuff there, and I just want to get off completely off of it because it's
And you're happy with the 8508 and 8588s?
I think the 8588s are great. Now, I'm never happy on the current side of things with any of these things, just because when you, for load cells, and someone probably knows that what I don't know is once you exceed that 20 milliamp range, you neck into like the really high uncertainty band. But I don't see people doing like a 0 to 20 milliamps and then, it's going to 24. Then we'll just reconfigure the meter and do all this other stuff. And generally they're not that great. If you've used these amplifiers and some of the stuff, they're not that great anyway. But a lot of the DA, that's the only thing I think that I've seen where I think the industry, and maybe somebody out there listening can ping me on LinkedIn or whatever, that there's probably something better for measuring current. But I'm really super happy with voltage and millivolt per volt, all that stuff. So
Fluke will definitely tell you the appropriate current shunt to get down there.
Well, that won't do it though, because I need to it's not the shunt though. I need to be able to measure through a full, without changing ranges, I need to be able to go 0 to 24. And the kicks.
Henry believes in magic.
Yeah, and it's just, why do they do that? Like, some things I don't understand. Somebody somewhere else say.
I will give them credit on the new calibrators. They specifically rearranged them to match the common benchtop multimeters, so those ranges are on top of each other.
Perfect for everything except for that 0 to 24 milliamp load. So yeah, because you have to use a higher range, and then it's still not that bad. We're still at like low uncertainties. It's just the range below it. I think the jump is from like 6 to 30, if I remember correctly. So it's like, it's 5 times when you start going to the higher range. The uncertainty just is, but it's still not bad. I don't want to say anything bad. I just, when you look at something, you want the better range, and it's like, if the customer just limits it to 20, or if it goes over 20, that was our argument. If it would go over 20 milliamps, that we'd have an issue. So it's like, we could just tweak them lower. We'll tweak them all to read 19.9 and we'll be good. We can be on the low range, but that wasn't something. In any case, it's a great instrument. I'm splitting hairs for down in the mud. Most people that are using current don't want to be as low as what I'm talking about anyway, especially on a load cell and on a data acquisition system.
For sure.
Yeah, it's knowing the audience. I did start a paper, which I think all of you would like. It's start with the end in mind, because I kept getting all these questions, and this feeds right into it, of like, well, how good can you be? And I'm like, okay, what do you do? And I'm like, well, why don't you tell me how good you want to be, and then let's work backwards. And that's just what the paper's about, is start with the end in mind. How good do I really need to be? Let's not start with getting the absolute best
That's
I
right.
can get with. Let's work it backwards and see.
Know your requirement, for sure.
Know it. Know the requirement for sure. Because people, sometimes it's like, the last person I talked to, like, well, we need to be manufacturer specs, and I'm like, which manufacturer spec? Oh, this nonlinear. We want our accuracy to be as good as nonlinearity, and I'm like, that's 0.03%. You actually, it turns out they needed like something nowhere near that.
Of
and
course.
It's like, yeah, you're going to have everything adjusted. You're going to fail everything all the time. And that's not good. I mean, if we're constantly failing something because your specs are, you deal with, this is a great conversation for all of them. If your specs are too tight and every year you send that in for cal and it's failing and you don't need it, why are you putting yourself and your quality department through that?
Oh, well, that happens all the time.
Ryan's a gun for hire. Do you ever get a request for, like, I need to know what my requirement is? I could see like that being really lucrative.
Well, so that's something we actually discussed, and I'm not ready to announce yet, but there's a project coming next year that is aimed towards customers of calibration that will cover some of that stuff. Yeah, because there is a need for that where, and it's going to be a free program, which is even better. So unless they want to get a credential out of it, anything credential-wise, we have to put a small paywall on there. But maybe I'll have to bring you on for that. You'll have to come into my peer review. I need peer reviewers.
Okay.
Be hard.
I'm really proud of you, man. Like, you're doing some cool stuff.
Trying, man.
I was thinking about it. I was thinking about you. It's like, you know, this is a hard industry and people's egos are very fragile and you're putting yourself out there. Do you guys, I'm sure you know him, Henry, but I've never met the guy, but I feel the same about Hogan. What's his ISO budget?
Hogan. Yeah,
he puts his shit out there, man. It's like, that's fantastic. You really
trying to think if I know Rick Hogan.
Really vulnerable spot.
He does some really good. There's some good blogs and some good articles out there. He did a fantastic one on guard banding, like the 11 different guard banding methods that he came up with. It might have been 13. It's one, and he explained them all. He did one on distributions, explaining all the distributions. That was really good. That
good common sense stuff to have.
They're digestible. Yeah, they're very digestible. Like the one I love Howard Kastrup's stuff, but sometimes you're going to go after it. I mean, this is like advanced, and you're going to have statistics galore, and I'm going to struggle with most of it, right? Most of his papers are such that I'll get to a part, and then there'll be a formula that's just forever, and I'm going to be like, oh God, I got to go figure out this, or I got to go ask somebody. But yeah, once you get what they're saying, it's good. But Rick Hogan's just has some really good common sense type of blogs that he pulls.
Nice. I just pulled him up on LinkedIn. We are connected, so I'll have to go. I just haven't met him in person.
Go read his stuff on distributions, because some of these distributions, I'm like, I have problems, you guys. I'm still having problems to this day, really figuring out, like. And Dilip and I talk, like, how often, and Paul, this is a good one, Ryan, how often do you guys use a triangular distribution?
I don't.
Teaching, never.
No.
There's actually times where I could see it being used, but I'm like, I get.
We teach that it's possible, but I don't use an example. I mean,
you can. I mean, like, Fluke will probably know immediately.
There's got to be some sort of specification that is better in the middle or something, and
I don't know, because it's like there's questions around it. So it's like you're using a U if it's cyclical or whatever, and even that, most people are just normal and rectangular are by far dominant, right? Yeah. Rectangular, you pay the price on rectangular because you don't know, so you're kind of giving a wider envelope of 115%. But and then you have the U. But triangular comes in. And Rick's thing on this, he gives an example on it, but he goes, there's so many distributions that are on there that none of us ever use. And it's a really interesting read. So I'd encourage anybody that's listening to go read Rick's stuff on all the distributions.
Rick down. I'm going to reach out because
I've got a binder I carry around that's got, I bought a bunch of his stuff, and it's stuff that and you probably do a lot. But having a reference to go back to like, because we're freaking getting old, right? Like me having to learn something new at this point in my life, no, that means that something in my brain is going to have to leave.
Yeah.
Right. That's where I'm at.
And it's
My
all your
business coach
Miramar.
always
It's all
says
your.
that.
It's your Miramar memories.
It's his popcorn. It's how it's what it feels like to sleep on peanuts. Is
that's right.
Gonna leave.
Paid the price.
My business coach says this. It's like you're exactly right. What do you retain? Like I'll remember stupid crap. Like, but yeah, I can't remember other stuff. It's like
it's what matters.
And
to you.
It's what matters to you. And then he just basically says, I write everything. I have booklets and all this stuff and write it down so that I can keep I want to keep all my client stuff top of mind and remembering that. But it is so everything's changing. AI is changing. All this other stuff is changing.
You guys talk about AI all the time too?
All the time.
Dorks. Oh my God.
I love it. I love it.
All right. When's the last time you called the electric company or you had to call your bank?
Last week.
Yeah.
What
do you end up saying? What do you end up saying to that daggone phone?
Representative.
Yeah. I'm sure AI will get there, but
it's not there. I mean, they call you. AI spam calls you with stuff, and sometimes
but it's spam.
I have yet to. I'm told it exists where you can have a conversation with AI and you do not know you're talking to AI. I have yet to
Where is
find
that AI at?
I don't know. It's coming. There's agentic. Now the big worry about AI is agentic shopping agents. So a lot of customer or companies want to bombard you like with a deal, and then they want to get you on the way out, like, oh, add this to your cart, do this. But the latest release for I think Chat GPT, I believe, is you can tell it exactly what you want, and it'll monitor like pricing for you, and then forego all the other BS and buy it. And I'm like, well, that's pretty cool. Then now I'm not going to add that awesome Smashing Pumpkins new album that I have to get because now they're going emo.
You're on the band. You shouldn't have to.
Yeah, I know. Well, today is the greatest. Today is.
And with that, gents, we are getting to the end of the time. What did we learn today? Well,
we didn't even talk about. We learned that Paul knows a lot about Star Trek now.
Well, I was going to say, I think actually the thing that I take, or that I would like at least students, and especially those of you transitioning out of the military, to keep in mind when you listen to Paul's story, is the wild ride that metrology is. Right, like you're not, especially if you're transitioning out of the military. Most of you are not going to stay in your first job out of the military. I'll tell you that much right now. No. And it's really hard to find that perfect job the first time around, especially in metrology, because it's such a wide variety of good labs, bad labs, and in between. And managers, right? Henry, we were talking about that earlier.
All the time.
You add in the managers and all that stuff. But those of you that are, the thing I'll say about you directly, Paul, is the incredible thirst for knowledge, but also the no take crap about it, right? Like I always loved, even when we were in the military, where you're able to call the BS, right? And sometimes I think the point that I'm at in our industry is we need those of you that are in the system and doing the right things to just kind of push forward with the right agenda. And we have to do our best to turn this industry around in those labs that are a little bit more questionable. What did you guys
help people out? Yeah, help people out with it. Like write something down. There are people out there that are experts on this. I write Jay, Paul or I can write Jay an email. We're going to get something back that is just going to solve our problems immediately. But you can help people out. Do a post, do a LinkedIn or whatever. Share some of your knowledge. If you're doing something really cool, share it. And see what other people are doing and see if you can help other people wherever it is. I also learned that Paul didn't. I wanted to add, the Star Trek stuff. You
got me there.
Yeah, that's awesome. We didn't talk about knives. Paul also collects knives, and he's got a relationship with the Texas Chainsaw Massacre that we didn't talk about. But
I do.
Yeah,
I forgot that already.
Where you grew up? You was close to that area. Yeah,
it was close. Yes.
Yeah.
Boom. Relationship.
That was an exciting story. I grew up where they filmed.
Well, Paul,
where they filmed Texas Chainsaw.
If people want to pick your brain, what's the best way to get a hold of you? LinkedIn?
No, I don't do any of that crap.
So LinkedIn. No,
smoke signals.
Is it okay because I'm on my phone all the time? Is it okay to give my number out?
That
If
is
you
up to
want.
you. I wouldn't do that if I were you.
You would do that?
Give your email. Give your email. That's
Yeah.
a better,
Do
probably
you have
a
an email,
safer
a
one.
neutral email?
Yeah. Pauly, Pauly, Depmore, Depmore at yahoo.com. That's the easiest way to get a hold of me, minus my cell phone.
There you go. In case you have any questions, you want to touch base further with Paul. We'll have to have Paul back on, though.
Oh, yeah.
Because
This is big for me. I was nervous that I was gonna drop a bunch of
we only got
F-bombs and start
into
cursing
all
people
about
out.
you this time. We need to get
Yeah.
juicier.
Yeah. Okay. Ryan, I'm really proud of you, man. Henry, you're a fantastic dude too. Thanks for having me on.
Appreciate it.
Thanks for being on. And I can't say enough about Ryan and what he does for the school. And I can't thank you enough for being on and sharing your story and stuff. The
Dang, I'm
pressure
loving
stuff.
the end of this episode. This is great.
Yeah. And we learned. What else did we learn? We learned that Paul does think you're sexy, Ryan. At some point in time.
No question.
There we go. And thank you all for watching.
Yeah.